Okay guys, we're doing lesson 31 today. And before you do anything else, I need you to read from pages 211 over to the top of page 215. So you may want to just stop the recording now and go back and read those pages before you watch the rest of the video. So the first thing it talks about is symmetry. If I draw a parabola, remember the parabola has an axis of symmetry, so that whatever is drawn on this side of the parabola is reflected over here, so that this dotted line is the axis of symmetry. The next thing it talks about is a reflection. So if I have, let's say that I have a curve over here and I want to reflect it about the y-axis, it would be over here. So the y values here match up, okay? Like this one matches with this one with this one, and so on and so on. What we did here was we took the x's and changed them to negative. So this would be f of negative x. So the x value changed to the opposite. If I have something that's reflected about the y-axis, like something like this, now the x values are the same, but the y values are the opposite. So remember, y equals, but f of x is just a fancy way of saying y equals. So it's actually the y value or the f of x value that changes sign when it's reflected about the x-axis. All right? So that's reflections. The next thing is translations. Trying to get to the next page, you guys. A little while ago, all I had to do was click on the page and it went. And now it's not working again. So bear with me. I'm trying to figure this out again. No. It's just not going to the next page. I don't know what's happening. All right. So if it's a translation and I have a parabola that's here, a translation could be that it's shifted up here or it's shifted over here. So a translation, if it's straight up and down, and this is on page 214, if we said that that was f of x was equal to x squared plus 1 to start with, that would be this original graph. This one looks like it's like 3 units up from that. So it would be f of x equals x squared plus 1 plus the 3 units that we added to it, or x squared plus 4. When you move it up or down, it's exactly the amount that you either move it up or down. So this one would be f of x is equal to x squared plus 1, but it looks like we moved it down 1, 2, 3. So it'd be minus 3, or f of x is equal to x squared minus 2. Now, when you move it on the x-axis, in other words, if we have this is the original, which is y equals x squared, and I want to move it over here instead, I moved it over 1, 2, 3, 4, 5 units to the right. And the way that we indicate that is we put x minus 5 quantity squared. Notice it's in parentheses. And it's the opposite of the way that we moved it. Because if you take this x minus 5 and set it equal to 0, it gives you x equals 5. So on the x-axis, we always have to put it in parentheses, and it has to be the opposite of the way it's moved. So if I move it over here, now it moved over 1, 2, 3, 4, 5 units to the left. So this one would be y equals x plus 5 quantity squared. Okay, this one is y equals x minus 5 quantity squared. All right, so if it moves up or down, if it goes up, it's a plus. If it goes down, it's a minus. But when it moves left or right, it's always got to be in parentheses, group with the x, and it has to be the opposite of the sign. All right. Okay, so on page 215, it says the graph of the equation y equals square root of x is shown on the left. All right, so it looks something like this, right? It says the graph on the right is the same graph reflected in the y-axis. Write the equation of the graph on the right. Well, if we go like this, sorry, it's supposed to be the same height. If all we do is go to the left, then what did we change? Did we change the y values? No. We changed the x values. So instead of it being y equals square root of x, it's going to be square root of negative x. Now remember, that's this graph right here, because it looks funny to have the square root of a negative x. But over here, all the x values are negative. So negative times negative means we're taking the square root of a positive number. Okay, we flipped it across the y-axis, so all we did was change the x's to negatives. So look at the next one. We start out with the same graph. Y equals the square root of x. And then it says the graph on the right is the same graph reflected in the x-axis and translated 3 units to the left. So we're changing two different things. So it's reflected in the y-axis, so that means, or in the x-axis, excuse me, so that means the y value is going to change. So I'm going to do that right now, because this guy is coming down here instead. Okay, so we change the y's to the negatives. In addition, we're moving the x values 3 units to the left. Remember, I told you when it's in the x-axis, you have to put it with the x in parentheses, and in this case, it's under the square root, and it has to be the opposite of the way it's moving. So it moved 3 units to the left, so this has to be x plus 3. Now, typically, we don't want something solved for a negative y. We want positive y. So I'm going to divide by that negative on both sides, so we'll end up with y equals negative square root of x plus 3. All right? Okay, so another one on page 216. It says, let me get to another page. Graph the equation y equals 1 over x. Then write the equation of the graph that has the same shape but is translated 3 units to the left and 4 units down. All right, so the easiest way to graph y equals 1 over x is to start with the graph of y equals x, which remember is a line that just goes like this. Okay, so that's the original, y equals x. Now we'll graph y equals 1 over x. And we did that. Where did we do that? Let me see. Hold on. I don't remember where we did that. It's the one that I showed you. Where you have to graph the reciprocal function. So we look for everywhere it crosses the x-axis and we put an asymptote. So This is supposed to go through 0, 0. Sorry about that. So this becomes a dotted line. That's an asymptote. And remember, where the graph was 1, it's going to stay there. And where the graph is -1, it's going to stay there, because the reciprocal of 1 is 1, and the reciprocal of -1 is -1. So then we pick a point in here. So I'll just make a table so we can see what's going on here. I'll pick a half, and then I'll pick 3. And then over here I'll pick -1/2, and I'll pick -3. So we put those in right here because those are the points we're going to graph. So 1 over 1/2 becomes 2. 1 over 3 is 1/3. 1 over -1/2 is -2. And 1 over -3 is -1/3. All right, so we graph those points over 1/2 up to over 3, 1, 2, 3, up 1/3, -1/2, -2, so down here, and -3, -1/3, so like right here. So the graph looks like this, and like this, and then it says, write the equation of the graph that has the same shape but is translated 3 units to the left. So the 3 units to the left will be x plus 3. And then 4 units down will be -4. So there's the equation of that graph that's made those translations on it. And it doesn't ask for us to graph that. If you look towards the bottom of page 216, they show you the graph of that shifted down and to the left 3 units, so you can see what it looks like. If you did have to graph it, the easiest way would be to take these 3 points on the right and the 3 points on the left and physically move them over 3 and down 4 and then connect the dots again. That's the easiest way to graph a translation. All right, so that's all of lesson 31. That'll be due on Monday. I'll do a video for lesson 32 as well. That'll also be due on Monday. And I'll give you the review problems as a picture in Canvas so that you can see what the review problems are, and we'll take the test on Monday. All right, thanks guys.